Okay, we are going to do the entry task, and this is for either 5-3 or 5-4, or I'm sorry, 5-5, depending on which day you guys have class. So the first one, what is the height? So we're looking for height of a 78 kilogram firefighter on top of his ladder with 11,466 joules of potential energy. So we're looking for height. We're given a potential energy and a mass. We know, though, we need a potential energy, a mass, a gravity, and a height. So I'm going to write out all the variables. So potential energy is given to us, 11,466 joules. So I'm going to write that for potential energy. Mass is given to us at 78 kilograms. We know gravity, 9.8 meters per second squared. Remember, you're going to have to remember gravity for the test. And the height is what we're looking for. That's going to be x, and height is found in meters. So if I need my equation, I'm looking for height. I'm going to cover up the h. I'm going to get potential energy on top, mass and gravity on bottom. So my equation will look like this. Height equals potential energy on top, mass and gravity on bottom. So I'm going to multiply mass times gravity, then divide potential energy by that number, and I will be good to go. So h is height, x meters is my h, equals my potential energy on top, 11,466 joules, dividing that by my mass times my gravity. So my mass is 78 kilograms. Multiply that by 9.8 meters per second squared, keeping the squared inside the parentheses because it's just part of the unit. Okay, so I got to start by multiplying everything on the bottom. So I have 78 times 9.8, and that gives me 764.4. I can't do anything on the top. 11,466 joules get carried over. Since I multiplied on the bottom in kilograms times the meters per second squared, that's actually what I keep, is a kilograms meters per second squared. Okay, which we know as a Newton because it's a mass times an acceleration. We call that a Newton. That's a force unit. Okay, we'll get more into that soon. But anyways, how do we get what we need? We have to divide. So 11,466 divided by 764.4 equals 15. And we know it's meters, but how do we get there? A joule is a kilograms meters squared per second squared. Kilograms cancel. The meter and this second, or I'm sorry, the squared, because it's a second meter, is canceled. The second squared are both canceled. That meter on top is left. That's what gives us 15 meters. So the firefighter is 15 meters up on their ladder. Okay, what is the kinetic energy? So now we're looking for kinetic energy of a 0.43 kilogram soccer ball moving 25 meters per second. So now we have a mass, we have a velocity, and we're looking for kinetic energy. So K, E, M, and V are our units. I talked too much already today, guys. Okay, so I'm looking for kinetic energy. That's going to be X. Remember, our unit is joules. Mass is 0.43 kilograms. Velocity is 25 meters per second. So I know the base equation is kinetic energy equals 1/2 mass times velocity squared, but we need to find that by plugging it into this equation. So if I didn't remember the base equation, I could cover up kinetic energy and know that a half mass is next to velocity squared, meaning they're multiplied. So my equation is kinetic energy equals 1/2 the mass times velocity squared. So I'm just going to plug in. So I have kinetic energy, which is x joules, equals 1/2, and I'm going to put parentheses around it so I remember to multiply. 0.43 kilograms is my mass, and I'm going to multiply that by my velocity, 25 meters per second. Put the squared outside the parentheses so I remember to square everything, including the units inside. All right, so now I need to take care of these individually by squaring and halving, and then I can multiply those two numbers together. So 1/2 times 0.43, you can either just divide it by 2, or you can multiply it by 1/2 or 0.5. 0.5, which is also a half. So I'm going to do that. 0.5 times 0.43. So if I knew to divide that in 2, I would have it. Did I say 0.43 or 0.44 on the, oh, sorry, 0.42 is the, not 0.43, it's 0.42, guys. I was like, that number doesn't look right. Here we go. Sorry, 0.42. Okay, so let's try that again. 0.5 times 0.42 equals 0.21, still a kilogram. And I'm going to multiply that by 25 squared. Once I get that, 25 squared is 25 times 25, which is going to give me 625. Now I've squared everything, meaning I have to square the meters and the seconds as well. Meters squared per second squared. Now I don't have a squared outside the parentheses anymore because I've squared everything inside. So now I'm just multiplying these two numbers, 625 times 0.21, and I get 131.25 joules, because a joule is a kilograms meter squared per second squared. Okay. Oh, I have this awesome tools there. There you go. All right, next one. What is the mass of a boulder that is rolling 34 meters per second downhill with 115,600 joules of kinetic energy? So we're looking for mass, we have a velocity, and we have a kinetic energy. So we need our variables again: kinetic energy, mass, and velocity. This time we're looking for mass, so that's going to be x kilograms. Our kinetic energy is given to us at 115,600 joules, and our velocity is given to us at 34 meters per second. So now I need to find the equation again. This time I'm looking for mass. So if I cover up the mass, I get kinetic energy on top of velocity squared. So my base equation is going to be 1/2 mass equals kinetic energy divided by velocity squared. Now, I'm not going to go through the whole process, but we have to get this so m's by itself. So remember, you're going to end up here. Mass equals kinetic energy times 2 divided by velocity squared. So that's going to be our actual equation we're going to use. And you should have this in your notes multiple times, and it will be on the test for you. So I'm not going to go through this process of how to get from here to here again, since I've done that multiple times already. Okay, so we need M. So I'm going to box that in so you remember we're looking at that one. So mass, x kilograms, equals kinetic energy on top, 115,600 joules. And we're multiplying that by 2. Don't confuse that with a squared. We're multiplying that by 2 because that's how we got rid of this half over here. And dividing that by our velocity, 34 meters per second, squared on the outside of parentheses. So we remember to square everything inside the parentheses, including the units. So I have to solve everything on top first, solve everything on bottom, then I can divide. So let's start with the top, 1,600 joules times 2. So I get 231,200 joules. And I'm going to divide that by 34 meters per second squared. So I have to do 34 meters per second times 34 again because I'm squaring it. 1,156. Now I square these as well, the units, meters squared per second squared. So now I can divide 200 divided by 1,156 equals 200. So my unit, a joule, kilograms, meters squared per second squared. I have a meter squared per second squared on bottom. I have one of those on tops, leaves me a kilogram. That's what I need, mass. 200 kilograms is the mass of that boulder. Okay, what is the velocity of a 6 kilogram eagle diving for prey with a kinetic energy of 675 joules? So now we're still in the kinetic energy. K, E, M, and V are the variables we need. So Ke is given to us at 675 joules. Mass is given to us at 6 kilograms. Velocity is what we're looking for, which is x meters per second. So if we're looking for v, I'm going to go back to my circle. I'm going to cover up v squared, and I get Ke on top of 1/2 mass. So the starting equation looks like this. Remember, I don't like the half down there, so I'm going to get rid of it, and ultimately also get rid of the squared on the v to get it alone. End up with v equals the square root of the kinetic energy times 2 divided by mass. So I got rid of the half and I got rid of the squared, and that's what I'm going to plug everything into. Okay, so let's do that. V is x meters per second equals the square root of my kinetic energy, 675 joules, times 2. That's why the parentheses are there. It's not a squared, it's times 2, divided by my mass of 6 kilograms. So I have to solve everything inside before I take the square root. That means I also have to square or do what's on top first before I divide. So I need to multiply 675 times 2, and that gives me 1,350 joules, dividing that by my 6 kilograms. And I'm going to bring over my square root sign because I still have to remember to do that. So 1350 divided, I hit times, divided by 6 equals 225. Now, I'm not done yet because I have to bring over my square root again. And I'm going to figure out what units came over here. A joule, kilograms, meters squared per second squared. Kilogram cancels, kilogram cancels. I still have a meter squared per second squared left. Good thing I'm square rooting though. So 225, flip my calculator over, and I'm going to hit the square root button. And 225 square rooted is 15. And I'm also square rooting the meter squared and second squared, getting rid of the squareds, giving me 15 meters per second. Here we go. Now we need to do the last one. What is the potential energy of a 7 kilogram box, 2.8 meters up? So I need a PE, M, G, and H. I'm looking for potential energy, so I'm going to go to my base equation of potential energy equals mass times gravity times height. So if I don't remember that, I could always use a circle and say, oh yeah, cover up PE, you get M next to G next to H, mass times gravity times height. Okay, so I'm going to write that down to remember. PE equals M, G, and H. My potential energy is what I'm looking for, so that's going to be X joules. My mass is given to me at 7 kilograms. My gravity is not given to me, but I know it, 9.8 meters per second squared. And my height is 2.8 meters up. So I'm just going to plug it into the equation. So PE is X joules equals my mass, 7 kilograms, times my gravity, 9.8 meters per second squared. Keep the squared inside the parenthesis because it's part of the unit, times 2.8 meters. And I just multiply them in any order all the way across. Across, not across. That's not a word. Okay, 7 times 9.8 times 2.8 equals 192.08 joules of potential energy. And that is it.